What we have today is resultant of more than two vectors. Now, we can have more than two vectors acting at a point like this. We have vectors or forces. Force is an example of vector. Let's call this one F1 acting at theta 1. Let's call here F2 acting at theta 2. Let's call here F3 acting at theta 3. Means X should be here, should X3, that is theta 3, F3, here should be F4 acting at what? Theta 4. Now, if these are several forces acting at a point, and probably if all of them are in equilibrium, if the forces are in equilibrium now we can now resolve these forces into two components called vertical component and horizontal, called x-axis. This side is called x-axis, this is called y-axis, this is negative y, this side is called negative x. So for us to find the resultant of these forces now, we need to resolve it into two components. Now, resolving it into two components, that is, here is called the vertical, here is called the vertical, here is called the vertical, here is called the vertical. So where here is the what? The horizontal. Here, x is positive, and this side, x is negative. This side, y is negative, and this side, y is true. So we can resolve it into two components called, contain here, horizontal component, that is x-axis, and the vertical component, that is y-axis. Now, using SOHCAHTOA, if here we want to resolve this force in the horizontal component, you now look at this point. This is x. So adjacent over hypotenuse will be cos. That is to say, cos theta equals to adjacent over hypotenuse. So from here now, our adjacent is x, positive x, and our hypotenuse is f1. So if you cross multiply, you now have x is equal to f1 times cos theta 1. So you do the same. Now, let's do vertical of this. Let's resolve this in vertical component. So this will be now opposite. So we'll now use sine theta equals opposite over hypotenuse. Opposite over hypotenuse. Our opposite here is y. So we say y over f1. So when you cross multiply, you now have here y equals to what now? f1 times sine theta 1. So we have resolved this single force now, f1 into two components. So we'll do to f2, f3, and f4. f2, f3, f4. So, but now in this case, when you come to this side, it will be negative. So here we'll now have our x will be what? Minus f2 cos theta 2. This side now, our y is still positive. Here now, our y, this is x is negative, y is still positive. So here, our y will still give us f2 times sine theta 2. Come down here now. Here, x is still negative because we are using this to resolve it. X is still what equals to what now? Minus f3 cos theta 3. When you come to this side, then y now is both negative this side. Y is negative now. So you now have y equals to minus f3 times sine theta 3. So when you come to this, now x is what now? Positive. So you now have x equals to f4 cos that is called cos theta 4. You know that cos theta 4 and 4, I mean, F4 cos theta 4 is the same thing as F4 times cos theta 4. So you can still put, I'm economizing my board. Now this place will now be, so y is still negative this side, we will now have minus y, sorry, minus F4 times sine theta 4. So I can equally put all of them times 2, in order not to confuse some of you, let me put all of them times so that I will not confuse all of anybody. Because some people will say, why are you putting times here and you are not putting it, still the same thing. So this is negative. So now, at this point now, we have resolved all these forces now into two components called horizontal component and vertical component. The next thing now is summation. That is, you add the values here. You now say summation of x now and the summation of y. Now, once we are done now, we have obtained two components. These forces now has given us these forces now. We can equally now, we can now find the resultant of it now. We can find the resultant of this. But there are things I want you to note before we can take example. Before we take example to show what we have done, I want you to note this. Note the number one. If this is called summation, this is sigma. That's what I mean. That is what this thing represents, not ex. This is sigma. So if you look at if sigma x, summation of x is negative, and if summation of x is negative, I can claim this now. If summation is negative and the summation of y is positive. Now, the diagram you will draw to represent these resolved vectors will be this way. Then you will put your this alpha means direction. This is not the resultant. This is summation of x. This is summation of y. Now y is positive. This is the drawing. How the drawing will take shape. And this is the formula for calculating what now the resultant. Using from this formula is gotten from Pythagoras theory that hypotenuse square equals to opposite square plus what? Adjacent square. Okay. If we now have, if f of x, this is 2, is positive, this will go this way, like I was trying to explain. This will now be, alpha will be here, the resultant will be here. This is summation of y, this is summation of x. So your r will be the same thing, summation of x squared plus summation of y squared. Then your alpha will be equals to tan inverse of summation of x over summation of y. Then if you want to represent it, it will now be not alpha degree east. Not alpha degree east. That is what it will give you. Now, if, this is when both are positive. Now, let's check when this y is negative. When y is negative, it will go this way, meaning that x is positive. So here is summation of y, here is summation of x. In the same case, this is your r. Then we will now have what? This will be your alpha. So your alpha, our r still remains summation of x squared plus summation of y squared. And our r, alpha, which is the direction, will now will be. Why do we always obtain this? This alpha, I call it direction. You know that when you talk about vector, you must have magnitude and direction. This one is standing as magnitude, and this one is standing as direction. So in this case now, you will represent it as what? South. Once it goes down, south alpha degree east. Then when both are negative, when both are negative, let's say both of them are negative, this diagram will change into negative. Here is still our alpha. Here will be summation of x, this is summation of y. So in this case, the same, here is r. R will still be square root of x, summation of x plus summation of y squared. And our alpha will still be 17 as tan inverse of summation of x over summation of y. Then you will still represent it as what? South alpha degree west. So this is the direction. This is the resultant. You must obtain direction and resultant when you are solving vector. So now, watch out for example. Thank you.